Well, you know who I am, and I've been fox hunting for, oh, 25 years. Might have been my first one way back in the 90s when I first joined GARS. You know everything else pretty much about me. Jim, you want to? We don't have our program guy here to do the intro, but if you would just go ahead and intro yourself.
Okay, I'll try that. So my name is Jim Sorensen, KA for IIA, and I'm going to try to see if I can't do a T-hunting presentation. Some people call it fox hunting, some transmitter hunting, lots of different kinds of names for it, but it's basically hunting a transmitter. And as Joe mentioned, you're going to have a fox hunt this upcoming Saturday. I'll be working with Joe, and Tim is also going to be there. And we're going to work with people that maybe haven't really gotten into that part of the hobby yet to kind of work through. We'll have equipment there in case you don't have equipment. We're going to have multiple little foxes and stuff. I think you're probably going to mention more about this, right?
Yeah, we'll have one fox with some instructors around it. You're going to be able to see the fox, so you're going to have a point of reference. You're going to see how the different techniques and different technologies maybe that affect how you detect and find these foxes. And then once you want to, or anybody else that doesn't do that kind of an instruction, there'll be a second one nearby that you can go and DF yourself. Then we have the bigger fox, which will be outside of that park that you'll have to go to and get the a code off of it, right? And then bring that back to the registration desk so that you could be given opportunity to go find the micro fox or the pup, as we're calling it. So you find mama, you find pup, get a certificate, get a token of appreciation, and hopefully have just a great time. I didn't say where the pup was. I said the registration table will tell you about how to find the pup. Good try. Go ahead.
Okay, so I guess to get ready for that, let's go ahead and have a presentation on transmitter hunting. Now, I'm looking around the room. I see some people that I know have been in the hobby for a while. Who here has not done any transmitter hunting? Really? Okay. I would have thought that there was less of that. So I know that we want to try to get out of here about 9. So what I'm going to do is I'm going to go through these slides at a fairly decent rate, but I'm going to camp on the ones that are more appropriate for new time fox hunting enthusiasts that don't know they're that. And then some of the ones, some of the more advanced stuff, I'll just kind of gloss over. If there are any questions, feel free to stop me as I'm going along. I'll do my best to answer it. You know, I can't even remember when I first started fox hunting, but one of the things I love about amateur radio, and as most of you that have been around for a while know, that there's so many facets of the hobby, right? You've got people that are CW enthusiasts, you got DXers, you've got people that do SATCOM. I mean, just go down the list of all the different modes of operation for amateur radio. And it's one of the things I really love about this hobby is that if you're into electronics, you're into amateur radio and any kind, there's something for everybody out there. I know that not everybody is really into fox hunting, so I hope during this presentation you can take something away maybe that'll pique your interest if you've never had an interest in it before. And like I said, if there are any questions, I'd be happy to try to answer it. If not, I'm sure Joe or Tim can make something up. Okay, so, all right, so I shouldn't have done this little thing. I try to not do that for regular presentations. But here's the agenda. So we're going to do an introduction. I'm going to try to talk a little bit about how all this started out, the history of it. We're going to talk a little bit about some applications that the world out there uses for transmitter hunting that maybe not necessarily related to amateur radio, but maybe is. We'll be talking about some of the equipment, some of the basic equipment, and then some of, like I said, I was going to kind of glance over or gloss over the advanced T-hunting equipment. I like to look at the software, and then I kind of like to walk through the phases of a hunt, especially if you've never done it before. There's some practical thoughts and ideas that you might want to think about if you decide that you want to get into that. And we'll have some tips and then Q&A at the end. All right. So, direction finding, fox hunting, transmitter hunting, it pretty much started at the very beginning of radio itself. And one of the reasons for that is just trying to figure out where you were going to at least transmit to or receive from to help get a better signal. Obviously, they realized that some of these antennas would allow them to, especially like this in this case is a loop, would allow them to get a better signal. So with the fact that they're trying to transmit and receive from stations that are halfway around the world, people started playing around with antennas and trying to figure out where they were talking, where the signal was coming from. Just a little trivia up there in case you happen to be on Jeopardy or something. It was 1902 when the first patent was granted for direction finding antenna. All right, and then of course I'm sure that everybody's heard about how some of the people in England do. They're really into having a television or some type of equipment in your house. They would crack down on people that were illegally transmitting. That's a picture. If you can't read it at the bottom, it's a British Post Office RDF lorry from around 1927 using finding equipment on a very old automobile. And some of you also may know that during World War II, direction finding became almost a key part of the U-boats, going after the U-boats. They were direction finding a lot of the transmitters that were on the submarines, and they were able to go out and hunt down some of the U-boats. So that actually helped turn the tide in World War II because the U-boats were decimating some of the shipping lanes back at the beginning of the war, actually before we got into it. And then at the bottom, you can't see that. It's a Wallenwerber array. It's a very, very, very large array of antennas. I don't know if you've heard of. They had them around the world, and I believe there's one that's still out there and it's operational. I don't know why, because they have much better equipment now. But I don't know how many football fields across it was, but it was able to DF HF waveforms, and they had enough of them around the world that they could triangulate pretty quickly on it. All right, some other real quick applications. So I work in the defense industry, and I know that the military has really invested a lot of money in direction finding equipment for troop movements, help for communication. Radar is really a form of direction finding if you think about it. And then the maritime and aircraft realms, you've got navigation beacons, distress shipping locations, and all kinds of ADF and downed aircraft. If there's a crash, it'll automatically set off a beacon. Fun fact there was a Russian satellite, right, that would circumnavigate the globe, and I guess every pass that it went by, it would help triangulate it. I don't think we had a satellite that would do that. I think all that's moved up into the 400 megahertz range, and then they've got some other equipment now too that makes it a little bit more modern. Okay, I know a lot of you have seen 4 antennas on top of police cars. So that's LoJack. Again, I'm talking about some of the applications now that you'd find out in the real world that people are using for direction finding besides amateur radio operators that are going out and playing. But LoJack has been around for a long time. They are now phasing out that system, probably because there's much better ways of doing that. I know for a fact that if you tune to 173.075 that you'll hear the transmitters, not the ones in the cars, but the stations. They're still squawking out there because I play with that with my direction finder equipment. So I don't know why that's still going, because I understand they're I think they've actually retired that. I'm seeing less and less police cars that have the 4 antennas on there. It's also used, direction finders used for wildlife tracking. Or you've probably seen it on some of the animal nature shows where they put collars around animals that they're trying to find and figure out, what kind of life that they're living in, that kind of stuff.
And in certain circles, I'm seeing where they're putting them on their model rocketry, because some of them on the high-powered launches, of course, those are just certain parts of Georgia that can do that. They'll file with the FAA and everything, so they get a rocket that goes up and it may catch a wind and go down, so they'll track it with these things, including I've seen some on the model airplanes. So I don't know if that's just for fun or not, but another application.
And then the last thing that I've got down there is the ePlurbs, which is at 406 megahertz, I believe. It's so what people were doing back in the day, as I understand it, is they were getting some of the ELTs and taking them with them when they were hiking and stuff, and then they would pop those off if they had an emergency, which is not a good thing because that was mainly, I think, for aircraft and probably shipping. So they came up with ePlurb, which is the emergency personal locating something device, and that's there's a picture of it at the bottom. It's yellow, and you can buy those in various flavors now for your own personal type use if you're out and about and you get into an emergency. All right, so the Bible that Joe was talking about, this is the Transmitter Hunting Radio Direction Finding simplified book. It's been around for probably since the late 70s, maybe early 80s. It's a very, very good book. It's making its way around. It has a way to build, or has plans in there on how to build pretty much everything you're going to see in this presentation, and then some. The guy that's one of the guys that wrote that is the one that does 73, does a column in 73, or did. So it's a really good book. I think it's in its second printing, and I don't know if it's really easy to find on Amazon. I did look on Amazon. I think I saw a bunch of used copies. But if you're interested in the hobby, I would definitely try to pick up this book. All right, so let's talk a little bit about the equipment that you'd want to use if you were going to get into this part of the hobby. So the first thing that we'll talk about is receivers, and I want to really kind of emphasize that, and you'll see that I'll do that. Then we'll talk about some of the different types of antennas, attenuators, sniffers, and preamps. Okay, so the receiver, in my opinion, is probably the most important part of whatever whenever you're going to try to do direction finding or find a transmitter. And there's the main reasons for that is, and we're going to go through the phases of the hunt in a few minutes, but when you start out, you may or may not hear the signal. So if you don't hear the signal, your receiver is key, because if it's a kind of maybe a scanner that's really broadband, or maybe some of the cheaper Japanese radios, yeah, I did go there. On the receivers, if it's a not very sensitive, you're probably not going to hear it, and you're not going to hear it very well. So sensitivity is key on that if you are starting out and you can't hear the signal very well. And then if you get into an area where there's a lot of RF interference, and I know more and more of that, I don't know about you guys, but as I'm driving down the road now, my VHF radio is just opening up. I've got to have CTCSS on almost every one of my outputs, because it looks like billboards and all kinds of signs are starting to interfere with VHF and UHF. But as that becomes more and more prevalent in the area that you're fox hunting, selectivity is going to be key. The ability to reject adjacent signals that are close in, or noise. Also, if for some reason the transmitter is like in an area where there's multiple transmitters, maybe up on a hill or a mountain or something like that, the selectivity is going to be key. So without those two, at least those minimal requirements being good, your limitation would probably be your receiver. I know generally in amateur radio we look at antennas as being one of the main drivers, but I think with transmitter hunting, I think your receiver, because you're starting out away from it and then you're getting closer to it, you got to have a nice receiver. One of the points I have up there, I believe, is key also. So generally, the receiver cost is directly related to the ability, the better sensitivity and selectivity, right? If any of you remember the old Motorola's, how they had multiple stages, multiple down conversions, very, very selective, very, very sensitive. Those radios are great radios. Now, they have some issues with the receiver's meter that they don't have on there, but the ability to pull out a signal out of the noise on a really good receiver is key. So I would say that if you're really getting interested in this and you'd like to do this kind of thing, you might want to consider spending a little bit more money on the receiver that has a better selectivity and sensitivity. So one of the other points up there is the broadband receivers, like scanners. And some of the, like I've got some communication receivers that go from 500 kilohertz up to maybe 2 or 3 gigahertz. Some of those are not as good as the ones that have band selectors in it. I have an ICOM RC100, I believe, and you can see when you start going into different parts of the band, you can hear relays clicking in. They're actually switching in different receiver elements. So. And they also have multiple antenna ports on it. So the higher end receivers are better than say maybe a really low cost scanner. And again, that's just because they're better, the better sensitivity and better selectivity. All right, I won't spend a lot of time on this, but if you have seen any of the block diagrams for a receiver, this is kind of a slimmed down version of it. And I put this up here because I wanted to make a point on the front end of the receiver. So this front end has a bandpass filter. That's that first block out there. All right. Right there. And it has a RF amplifier. Now this is very, very simplified. Some of these receivers will have multiple amplifiers. This would be a low noise amplifier here, and then you have your mixer stage, and then another bandpass. I'm sorry, this is a bandpass filter. This is a bandpass filter. The more sensitive and selective receivers out there have multiple stages like this with different filters and different amplification networks in there. And so if you go into some of the less expensive ones, some of them are doing almost direct conversion on the front end of that digitally, and then they're bypassing a lot of the front end of that, and then a lot of the stuff on the back side is being digitally processed, which is great because it gives you the ability to receive different kinds of signals. It gives you the ability to, do AM, FM, sideband, and stuff like that. But you're bypassing the sensitivity and selectivity of some of the older radios. So it's kind of a trade-off. If you look at, like the old Kenwoods and Yaesus that are the double conversion receivers, they're really good. So if you go maybe to a Hamfest and you see a receiver there, an old handheld that still works maybe as a receiver, has a signal strength meter on it, it's an older kind, those things are really, really better than some of the newer versions that are out there. Okay, so the other thing on a receiver that you want to look for that's very important is your signal strength meter, your receive signal strength indicator, which is the bar that you can see up there on the top. The Baofengs don't have it, at least the ones that I know about don't. Maybe the new ones do.
They have a meter, but it's not real. It's either on all the way, you'll see all the bars, or you'll see none of the bars. So Baofeng's kind of hard to use if you're going to use it in the application of the RRSSI, signal strength.
So on this one, the picture up there shows a Yaesu, and I don't know which one it is, but it's got the signal strength indicator on the bottom, and I think it's in increments of dB, and then as it gets more and more to the right, you got a higher signal strength. And as you'll see, that'll become key as you start working with some of the other equipment. Okay, so one of the things that I've got down at the bottom that I want to make note on, some of the other equipment that we're about to talk about can be damaged if you turn on the radio and it transmits. I've seen some of the HTs, as you turn it on, the transmit light pops on. I don't know if that's just a flaw in the software or something in the hardware or what, but it makes me wonder if it doesn't transmit. So I would recommend that if you're using it on any of the switched equipment that we'll talk about up here, that you turn the radio on first and then you put the antenna on afterwards. I know that's kind of a pain in the neck, but that'll keep you from damaging. Some of the equipment is just extremely sensitive, and you'll burn it out if you transmit into it.
So basically, know your equipment, test it sometime, tune to a frequency, then turn the other one on, same frequency, then turn the other one on. If it boots up and you don't hear a signal, most likely it didn't transmit unless you can't hear a microsecond, perhaps.
Yeah. You know, one of the things I know probably a lot of people in here have the new SDR radios. You can pop it on the frequency and just watch the waterfall. And if you turn it on and you see a peg on that, then you know you've transmitted, and it can pick up microseconds worth of transmission. So that's the only way I would trust it. I don't know, but some of this equipment is a little bit expensive, and if you don't want to burn it out, that's what I do on my handheld. If I'm going to put it on with a switched piece of equipment, is I turn it on first and then put the antenna on it. So the other reason why I've got it on this slide is I'm talking about receivers. Sometimes you use a handheld because you don't have a receiver, and that's fine. I do that too. I just wanted you to know that if you're using a handheld like an HT, it is a transceiver, right? So it'll transmit and receive. So just I would recommend just being real careful with that. Okay, so I mentioned earlier we're going to talk a little bit about antennas. I know Joe's got a loop up here. So the loop antenna is a nice basic antenna. In the book that's going around, there's actually some plans on how to build a homemade loop. And I actually, on that page, a friend of mine built one of those, and it worked fantastic. He's got PVC pipe, and he's got some copper wire, and it has the dimensions for it. Very easy to build, and if you're first getting into the hobby and you want to learn how to use it, and you can get into this hobby with hardly any money at all. You might even be able to scratch up some of the equipment or parts and pieces at home, or you can buy a commercial version. Right.
This is a purchased one. It's pretty well built. It's one of the reasons I bought it. But notice the diagram and the patterns you see up there. That's actually looking from the top down of that loop. So you can see why in the middle, it's a null. And we have a little short video to show later how that really works well.
Right, Joe. So as you mentioned, what you'll do is you'll turn that antenna. As you turn it towards the signal, it's going to null out. So when you're watching the signal strength meter on your receiver or HT, you'll see that it'll start going down in length, which means that the signal is lower. And as you start turning it to the side, it'll get bigger. So as you're facing towards it, it's either that way or the other way. So that's one of the cons of this. I've got each slide for each antenna. I've got a pro and a con. The pro on this is that it's small, it's lightweight, it's low cost, you can build it yourself. The con, though, is that there is ambiguity, which means that if you're holding it flat face towards the transmitter and then you turn around to the back, so it'll look like it's either that way or that way. It'll be 180 degrees ambiguity. And one of the ways to figure out which way it is you can walk a distance and then do it again. And then as you do that, you'll start seeing that it can't be that way, it has to be that way. So, so you're kind of doing sort of like a triangulation on it. You get it flat this way, you walk, 100 feet that way do it again, and it seems to be that way, then you know it's not behind you. So that's one of the things you have to do with a loop antenna. It takes a little bit more time to do it, but it's very effective. A lot of people use it.
And sometimes just shielding. I'm not sure how effective that would be, but yeah, that would work too for the ambiguity part.
All right. So I know a lot of people have Yagis probably at home. They use them for long distance UHF, VHF communications. This is actually a picture at the bottom of a tape measure Yagi. You've probably heard about that. So the tape measure Yagi is a really cool thing if you want to make your first antenna for direction finding. There are a number of plans out on the internet that you can download, and you can basically use an old tape measure, cut it up, and then they've got a piece of PVC that's in there, and you can attach the tape on there, and then you can hook it up to your receiver. And you can see this. This is the pattern for a Yagi. A lot of you are probably familiar with that. So the front of the Yagi is pointing that way, and you can tell that because the back of a Yagi, typically the element in the back is longer than the front. So the back part has a longer element and the front part has a shorter element. In this case, it's hard to see that, but if you look at one, you'll see that that is the case. And what that does is this back one is called the reflector, and then you have the driven element, and then these are the directive elements here. And I'm not an antenna expert, but if you do all the math and all the equations on that, what it does is it phases the receive signal that's coming in and gives it directivity towards that way. So you'll see that the front end of the antenna has more gain. This means that it's stronger out here than it is on the back part. Now there are these little fingers that stick out that are called lobes, and if you're not careful and you're using this, you can get some signal strength on these side lobes, but they're going to be a lot lower in signal strength. So this first lobe up here will be your biggest one, and then when you've got it turned completely away from the transmitter, you'll have a smaller lobe back here. So the pros on the Yagi is it's low cost also because you can make that. It has a higher gain than the loop does. It's moderately easy to make, and like I said, there are several websites out there. If you just type into Google tape measure Yagi, you'll find it where somebody's done all the math for you, and they've got the plans, and you can just build it straight off of that. I know that Fayetteville Club, I think 2 months ago, they had a party where everybody brought their tape measures, and they sat down and they did it at their meeting. So the cons on that is this is actually a boom from, it's one of the Arrow, I don't have the elements on there, but it's one of the Arrow Yagis, and you can see it's kind of long. This one's a 4-element on VHF, so it can get in the way if you're swinging around and some brush and stuff like that. That's one of the reasons why people like the tape measure Yagi, is because if you happen to hit it up against a tree or something, it's not going to break it. This one, if I hit it on something, I'm probably going to break the elements off of it. But it's you have to manually rotate it. So what you would do, just imagine this having the elements on it. You would have your HT, and you'd watch the signal strength, and you'd start turning around. You go around 360 degrees and try to figure out where the highest peak is on your radio. And so you'll do that a couple of times, and I would recommend that you move off maybe 100 feet from that and do it again, because you might be sitting in some multipath, and we'll talk about a little bit more about that in a minute. But you might be in a signal or a place where you're bouncing off a wall or something like that. So anyway, what you'll do is you'll use that to determine which way the transmitter is coming from. So you probably noticed some of you that've been in the hobby for a while. These antennas, they look familiar. You're using them all the time. So the same reason you use to transmit with them works the same way when you want to receive, obviously, too. So if you wanted to talk to somebody far away and you had a Yagi, you'd point the Yagi towards the receiver that is listening to you to get the most gain out of it. And so the same thing for transmitter hunting. You do the same thing where you're listening and looking at your signal strength meter. You probably can't see that very well in the back. That's a quad. So a quad is a lot like a Yagi. The beam pattern is almost exactly the same. The thing about a quad is it's a little bit more compact, and it has about the same gain as the Yagi does with less elements, but it's a little bit harder actually to make, and it's a little bit harder to move around. But there are some people that like to use quad antennas for DFing. All right, so we've talked about antennas. Now we're talking about an attenuator, and we're going to talk a little bit more about why you'd use these in a minute. But the attenuators are used to knock down high intensity, really powerful signals. So let's say you're out in your transmitter hunting and you see that your meter on your receiver is pegged. It's all the way to the 20 to 40 setting. You can switch in. You can switch in an attenuator, and what it'll do is it'll actually make the receiver think that the signal has gone down in signal strength. And because what that's doing is it's really switching in some resistance on there to effectively, well, it's knocking the power down. The received signal power is being reduced by whatever the switch setting is.
This one has only 45 dB. The one shown is 65, I think, if you add them all up. So they're cumulative.
Right. So it has individual switches on there, and the one up here is marked 20. It has two 20s, a 10, 8, 4, and 2. What that is, those are dB attenuation settings. So
yeah, 20, 10, 5, 3, and so forth.
And the way you want to use this is you're looking at that. Remember on the receiver that I was showing with the bar on there that was showing signal strength. If it's completely maxed out and pegged to the right side, what you do is you'd switch that in till you're down to around 2 to maybe 6 dB, so you've cut it way down. And then as you're starting to swing it around or get closer to it, you keep adding attenuation so that as you get closer, you'll see that you're getting closer because the signal strength will get longer or more intense. And if you start going away from it, obviously the signal will go less. So attenuators are really, really good when you start getting into very, very sensitive high power signals. Yes, sir. That's a good question. So RF gain works really good when you're far away from it and you want to hear it, and we're going to talk about that in just a minute. But let's say that you're trying to find a transmitter, you've gotten in the area, and all of a sudden you see the signal strength meter. It's all the way to full power. And you're driving around. You've driven around about a mile, and it's always the same signal strength. It's always maxed out. And maybe you don't have a really good directional antenna. You're just trying to figure out the amount of power. Since it may be powerful enough that you can drive around 2 to 3 or 4 miles and it still be pegged. With this, you can switch in the attenuation, and now all of a sudden you've got half of the power, and as you start getting closer to it, you'll see it go full strength again. So now you're getting closer and closer. So it gives you the ability to look at a signal and say, hey, I'm getting closer to it. Whereas without that, you'd be driving around saying, it's everywhere. I'm seeing it, a 5-mile radius of it. Now, one trick you can do if you want to is you could take the antenna off your HT, and it should you shouldn't have any signal at all. If you got a signal that's readable or maxed out, you're probably within, a football field of it, depending on what the power is, okay? That makes sense? That's a good question.
There was one time we tracked down a guy, his microphone had fallen into his cup holder, and he's transmitting on 50 watts, and I'm driving around trying to find him and taking the antenna off. It's still full scale, so you had to do other tricks, and my trick case was tuning up or down 5 or 10, 15 kilohertz. So with at full scale deflection, bottom line, you can't see where it is. But if it's got variability, then you can start telling. If I'm coming up and it pegs, there it is.
So that's a good question, and I'm glad you asked that because that really helps understand why you would do one or the other. So we'll talk about a amplifier in just a minute. This one is the offset attenuator, which Joe has up here. So that's a commercial version of it that you can buy from Arrow. Some of you in here have probably know Arrow. They make direction finding antennas. They also make satellite communication antennas, and they make that that loop right there too. Do they make the loop? I think they do. Anyway, so the offset attenuator works a little bit different than a normal attenuator. So the attenuator that you saw on the last slide and up here, actually they're switching in resistance. And as you switch in more resistance, the signal gets lower, except when you get so close to the transmitter that now you're not going through the antenna anymore. So if you happen to take your antenna off and it's full scale and you're walking around and it's just full scale and you walk maybe, I don't know, 2 football fields around and it's full scale, then you have no idea where it is at that point. That's because what it's doing is it's actually going through the case on there, and it's going straight into the front end of the receiver. And you
I don't know if it worked or not, but I covered this one in tape foil.
Yeah.
I don't know if that helped or not.
So what the offset attenuator does is it cheats. You go, in this case, 4 megahertz off the frequency. So let's say you're at 145.00. So if you do the math on that, you go to 149.00, you go up there. Well, it's no longer, even if it's busting through the case, you're not tuned to it anymore. You're actually 4 megahertz off of frequency, but that has a mixer in it that mixes the signal so that as it mixes the signal, it changes the power that's going into it so that when you're receiving it, you can use the attenuator on the front of that since you're not actually on the frequency of the Fox. So the Fox, remember, or the transmitter, remember, is at 145.00, but you're mixing it up to 149.00. It's not there, but the image is there that's off of the mixer. So it's no longer busting through the case at that point. It's actually going through your receiver, and then it has a built-in attenuator into it, so you're able to practically get it down. I've never put it on
The last Fox I found with this, using this, and using the Arrow antenna, so it's a directional with gain antenna, and walked just about right up to a 25-watt Fox, and still could attenuate it down to just about nothing.
Yeah, I think it's got to knock it down to about 100 dB. It's really impressive. So that's what you need, something like that. And there's another thing in here we're going to talk about in a minute that will help you get right on top of the Fox or the transmitter if it's high power or even regular power. It'll help you find it. If there were 8 antennas lined up and you had to say which antenna it was, it will allow you to find out which antenna it is because that's capable of attenuating the signal down. And so up here, there's a schematic. Is that in that book?
It's in the book.
Okay. So there's in that book that's going around, there's a schematic that you can make your own, or I forgot how much that was at Arrow. I thought it was a reasonable price, especially $80.
Yeah, not what I paid for it a couple years ago.
No,
Well,
I
you can
think,
make
I
them
think
for
it was $80 when I bought mine, but
you can make these for little to nothing. You got a 5-volt regulator, a 4 megahertz crystal, a couple of really inexpensive discrete components, and there's your attenuator with a little watch battery if you want, or larger.
So the takeaway there is, and I'm sure that these plans are on the internet too. You don't have to buy the book. Okay, so you can find these plans, and if you want to make it that's fine. You're talking about maybe parts that you have in your parts bin at home. Okay, so this is a sniffer, and I know some people in here probably have some kind of a radio strength indicator in their shack that is not tunable. It basically just has an attenuator on it. It lets you know that you've got some RF power going out of your station. That's what this is. So really all this is, and you can make one of these too, it's the signal goes in to the front end of that, and then there's diodes in there that basically rectify that or strip off the RF into a cap, and then that cap just sums that voltage together, and it gives you a voltage there across that capacitor, and then you can use that resistor to change the current value into that meter. And all that means is that you can do almost what you can with the offset attenuator. You're just basically rectifying the RF that's coming into that sniffer, so it allows you to get in close to the signal on that too. The only kind of fault I would say with this is if you're in an area where there's a lot of RF, you're not going to be able to selectively get rid of the other signals. I mean, if let's say you're on a hilltop and there's like 10 or 15 antennas there, and maybe there's 200 or 300 watts per antenna, it's just gonna peg, and you won't know which one it is.
Or at a ham fest.
Yeah. So this one is not frequency dependent. It's basically just open to the world, whereas your offset attenuator will work with the frequency that you're tuning to. All right, and this is just a picture of an LNA. It's a low noise amplifier for pre-amplification. We'll kind of talk about that. So when at the beginning of the hunt, let's say you can't hear the signal. So the antennas that we were talking about, like the Yagi that has a lot of gain, and something like this will, you get up on a high spot and you'll be able to get maybe a bearing and go start hunting the transmitter. And we're going to talk a little bit more about that in just a minute. I'm not going to spend a lot of time on the advanced transmitter hunting equipment stuff because I think what we're going to be doing Saturday is geared more towards the lower technology, and I don't mean that in a bad way. It's just people that want to get into it and learn more about it and maybe have questions. I think they'll gain more by using the loop and the Yagi and some of those other pieces of equipment, which we're going to have. We're going to have a loop there, a couple of Yagis, and some other equipment, the offset attenuator, and some of the little mini micro foxes, and you'll be able to see how all this works that I'm talking about. So I'll just kind of flip through this pretty quickly. So the switched antenna, we actually have a little video for you on this. But what this does is, and you can make this, there's plans for that in that book also. Basically what you're doing is you're making two antennas that are dipoles that are a certain distance apart from each other, and you're switching between the two to your receiver. And what that does is that imposes a kind of a frequency shift on it as the antenna. So if the antennas are equal distance to the receiver, in other words, you're pointing to it, or maybe away from it 180 degrees, there's no shift on it because it's both antennas are getting the same energy at the same time. As you turn the unit, and like I said, we got a little bit better video. There's a little bit of a shift because one antenna is closer to the transmitter than the other, and that superimposes a slight shift in phase on that. And there's an audio, corresponding audio that comes with that. And you'll
They're shifting at audio levels.
Audio levels.
Back and forth.
Correct. And you don't necessarily have to totally understand that, but it is one way of doing direction finding. You want me to go ahead and run that video real quick?
Yeah, go ahead.
Okay.
I would say it acts, is this incorrect? It acts just like your ears? Just like your ears, as they would detect sounds and knowing what direction they were coming from.
The lights tell us whether the transmitter is to the left or to the right of the detector. So here's the detector. I'm now aimed in this direction. The car is where the transmitter is, and the two green lights on the left say the transmitter is to our left. I'm going to come around like this, One light says we're off axis, but not as much as two. And now it's saying this way to the transmitter. Come around a little further, and now it says the transmitter is to the right of where we're pointing.
Okay, so that was only part of the video. So the rest of
Right.
the video talks about you can turn it around the other way and you have the same problem. It could be either that way or that way. And what he talks about is walking over about 50 or 60 feet the other way and trying it. So you should kind of do a triangulation to figure out if it's that way or that way. And that is one of the downfalls of that system is the 180 degree. It means front or back.
Well, in this case, if the left LED is on and I keep turning left and it doesn't come into play, it's behind me. So I turn around,
Yep.
and then it says turn left, boom. I get past it, it's a null, so there would be no LEDs. So it would behave properly if you're facing it. That's how you know the difference between forward and back. Yeah. Well, what I like about this too is I can walk. It doesn't matter about the power level because it's detecting phase, so I can walk right up to the transmitter, and within a degree or two, it'll go null. So I don't know. No attenuation needed.
So one of the benefits to the one you have there versus the one up here that's handmade, because I did make one of these, the elements that you cut are specific for the frequency. But the one he's got, you can do a little, yeah. Now the phasing distance is a little bit part of it too, but it's probably not as bad. So you can do 440 with that probably, okay, yeah. Okay, I know there's some folks in here that are into avionics. So the Elper, little Elper, have you heard of that? Any Civil Air Patrol people? Okay, so the little Elper, I don't think is made anymore. If it is, it's probably that one up on the right, but I know the one on the bottom is out of production, although I understand there's people that want to buy that. That was crystal controlled on the bottom. The one on the top is more synthesized. So that was geared more towards radio aircraft, ELTs, that kind of stuff, in that specific band. And I think they do have the one on the top, I think, can do also the 440 frequencies. But again, this is just some of the advanced stuff that's out there. I don't want to spend too much time on it. I think so, yeah, if I can get to it. You want to do that? Okay. All right, let me see if I can.
This device I bought at a Hamfest. I got a really good deal. It's the VK4 sniffer by VK3YNG, and they're not available right now. They can't get the source the parts, but it's a really all-in-one. It's a receiver. You can punch in the frequency. You can store the frequencies, and it has different modes and so forth. Basically, if you've ever heard a metal detector come upon its desired spot, that's what this will kind of do. And also what I like about it too is I can put headphones in it. I can hear on one side that frequency, on the other side the actual transmitting frequency if I choose to use that for some reason. But the thing that's cool about it is it has a built-in attenuator, so no matter how close I get to it, it'll keep knocking it down in attenuation and keep giving me that detection on where it is. And this can be used, well, like this 4 megahertz offset. You can use it with any antenna. I can use this with any antenna. The videos we're going to show the loop and a Yagi. So, okay, and that's fine. It just shows, and I in the video I got the camera right behind it. So as I come to the source of the antenna or the Fox, you see it in the background, and it just goes. And it's just a great tool. It's just a great tool, but it's $400 some. I didn't pay that at the Hamfest. I really didn't. And no, it's not outside the park either. Okay. I don't know if there was anything else. So this is looking for the null, so you'll hear the meep, meep. Now on the Yagi, it'll be the opposite, of course. It would go rear, rear. Sorry, I can't do the better tones, but the Yagi was a different thing. This is the null, the Yagi's the peak.
Okay. You got all that on tape, right?
Rear, rear.
So the Doppler direction finder, I won't spend a lot of time on this. This is, again, if you've seen the police cars with the 4 antennas, it's the same technology. It's using the Doppler shift on it, the 4 antennas, to give you a bearing. And that one particularly has 16 LEDs on the front. You can't see them because it's black, but it has 16 LEDs in holes. And as you're driving, if the top LED is lit, then that means ahead of you. Obviously, the bottom one's behind you, and then it has the other 16 LEDs that help give you a direction.
And this is a KA4 IIA design.
Long time ago, yeah.
Long time
That was
ago. A couple of us in the club have these.
So the one thing about that I'll say is that to use that, you really need to practice, because there's a little bit of, if you're new to it and you're not used to how it works, it picks up a lot of multipath as you're driving around. So you have to really kind of watch the indicator, and in your mind keep an idea of which way you're driving and how it's going. Now, some of the newer ones, like Tim's got, it does some pretty heavy averaging and gets rid of that. Actually, the design for that one, except for the antenna switching part, is in that book also. The original audio circuit and control circuit was taken directly out of that book that's going around. That one does not have any of the processing, like what is the name of yours? It's the it was a K2 something. It's the one that you see out that is the only one that you can buy out there that I know of right now, and besides the Ramsey.
And there's the Ramsey kit
Yeah.
version. It's got the LEDs.
So
of
the
course, in the middle.
Ramsey is the exact same design as the one that was in that book too, if I'm not mistaken.
It is.
So, anyway, if you threw a Doppler in your car and you put the 4 antennas up and you started driving around, if you weren't really kind of aware of what was going on, you might get a little bit frustrated with it. It takes a little bit of practice to do, but once you learn how to use it, you can. The great thing about it, the pro, is that as you're driving down the road, you're getting constant bearings as the signal's on. You don't have to stop like the other antennas and turn them around and try to figure out the direction of the transmitter. This thing will give you a bearing as you drive. As a matter of fact, you really shouldn't take a bearing if you're not driving, because if you stop someplace, you might be in a multipath area and it might be pointing in the wrong direction. But as you're driving down the road, a lot of the multipath will start averaging out, and you'll get a general direction of where the transmitter is. Yes, sir. So that's a good question. It's based on the frequency. 2 meters, like that one, would be typically about a 440 configuration. The spacing needs to be around a quarter of a wavelength, not less. So if you start doing less than that, you can start getting into a ambiguity setting. I've seen where if it's a little bit wider than that, it's okay. You start going a little bit narrower, then things, you just have to play with it. The best way to calibrate one of these, I find, is driving down the road. I can see Stone Mountain on I-20. I live out in Conyers. So right about Sigmund Road, I got the Stone Mountain right in front of me, and as I'm driving, I should have my front LED on. And then I'll go up a bridge and turn back around, and it should be the back LED, and it does that. And that's how you do it. But if you try to calibrate that, just standing there and have somebody walk around, I found that you might be right in a multipath area, and you're getting reflections off of something. So now your bearing that you've calibrated on might be off a little bit. But to answer your question, yes, it's based on the quarter of the wavelength.
Yeah, calibrated out in the middle of a big, large Kansas wheat field. That'll be pretty good. I guess what helped me a lot when I was using this version is I was used to a flashing depth finder. I don't know if you've ever seen them, but they don't show a picture of anything. It's just flashes. And I would see the flashes go from varying depths and so forth. When I see these LEDs kind of going all like this, I ignore the ones, the occasional ones that would come down on the southern part of the dial, and then in my mind I would just average these. So
right. And the other thing on this, and I told you I wasn't going to spend much time on it, but we already are, you listen for the tone. So you have the radio turned up where you're listening to the the transmitter, and you're going to hear a buzz in there that's in this case, it's around 500 hertz. And you'll hear that, and if that tone becomes more pure, then that's probably a really good bearing. If you're hearing kind of a raspy kind of changing, and you see it changing, you're seeing multipath. And all the multipath is, for those that maybe not understanding that, if let's say you're driving down the road, and I know you can see these walls they have on the side of the interstate, right, that are made out of metal, and that's to keep sound out from the houses that are on the other side of the interstate. If you think about it, if you're driving down that and you got these metal walls on both sides of you, and the signal's on the other side of the wall, it's going to be hitting the other wall, it's going to be bouncing off of it, and then hitting your antenna. So you're going to think it's that way when exactly it's on the other side of the wall. And you're getting that by various things as you're driving around, like trees and buildings and houses and just about anything that's out there, you're going to get multipath off of. So that is one of the cons of this, is the multipath and the ability to kind of, but if you start getting good at, like Joe was talking about, like I guess the fish finder, which I haven't seen, you start getting to where you can read it and pick it up, and people have gotten really good with it to build it, to find transmitters pretty quickly with it. As a matter of fact, a lot of the hunts around lately they've banned the Doppler. They won't let you use that. You can use the Yagi, you can use any of the other antennas, but you can't use the Doppler because a lot of people don't have it, and if you're pretty good at using it, you can find the signal pretty quickly with it, and then everybody else might be a half an hour to an hour after that.
Or they just have another category.
Right.
30 minutes.
Yep. Okay. All right. I've already talked about this, but so he's got the Ramsey up here. Okay, so it's the KN2C DDF 2020T is the one that you have. That is probably the one that all of the amateur radio operators that really are getting into this, that want to buy a Doppler, are buying. I don't have a picture of it, but it has the 4 antennas you buy with it, and it has the display on the dashboard and all that good stuff. And I know Tim Lemon has got one, and I've seen it work. It works pretty good. It does do a lot of audio processing on it to get rid of the multipath, so you won't see it flipping around. It's pretty pretty steady. Now, if it's a really, really bad multipath, it'll swing around, but it's usually pointing pretty good at the direction. Okay, I'm going to kind of go through these pretty quickly. So these are some, again, the advanced transmitter hunting. I don't know if anybody here has worked for Rohde & Schwartz or heard of them, but this is one of their antennas, or part of what their antenna looks like. Basically what this one does is it's interferometry, and I know that somebody was talking about STEM, the education. They were doing some astronomy. So I think they were using this technique to do some of the interferometry. They use it in astrology too, or astronomy too. I don't know how that works, but I know what they're doing is they're measuring the angle of arrival on those antennas. There's 5 on that. I won't bore you with the details, but as it basically is, the wavefronts hit each one of those antennas, they measure the phase and they do a calculation on it. They can give you an angle of arrival on it. And according to them, the precision on it is about 1 degree, which is pretty good. I think the Doppler is 10 degrees best case. This is typically used by the military and commercial use. So if you go out to some special event like the Olympics or whatever, you'll probably see a truck out there with an antenna like this up on a mast. And again, they're using the interferometry on this. Okay, I bring that up because we're amateur radio operators. There is a device out there. Has anybody heard of the Kraken SDR? So if you do a lookup on the Kraken SDR, it's actually a very interesting device. It was developed by a team that is doing radio direction finding. They use SDR technology for this. There's 5 of them in there. The 5th one is a reference. And they're doing interferometry with that. The software for it is really, really impressive. So if you go out and look at their site, they're selling these. I don't know what the cost is. It's like $300 or $400, I think. And I think you get the antennas and you get the software with it. and as you're driving around, it's doing the measurements for you, and then it'll finally pop up a thing on the display and say it's here as it's driving around. Yes, sir. So I have seen some YouTube videos where they're bragging about, hey, if you have a club and you got a jammer, buy this. I'm going to tell you there are some pitfalls of this, and that is they're using SDR technologies, software-defined radio. So it's not as selective as you would think it is. But the software is very, very impressive. Maybe what they've done is they've built in some algorithms to take care of some of the. So if you drive through a high RF environment, how many people in here have an SDR and they've seen where something transmits and then you see signals right next to it? So it looks like it's the same transmitted signal right next to it, right? I've seen that too. What that is that signal is bleeding in on those other frequencies because that SDR does not have the selectivity that a regular transceiver does. They're great. They can scan, this particular one can scan over 2 megahertz, in a microsecond or whatever it is. They're very impressive, but they do have some selectivity issues that if you do want to buy something like this, you just have to be careful in a high RF environment. Okay, I'm just going to talk about this one really quick. Has anybody heard of time difference of arrival? So this slide right here was actually copied from a ham that was over in Germany who did a paper for, I think his PhD, on transmitter location using TDOA, and it's just time difference of arrival. And really quick, what he has is he's got 3 different receivers, located, let's say one on Stone Mountain, one north Gwinnett, and maybe one in Atlanta. He synchronizes these receivers so that when he receives a signal, they are able to, and I'm gonna really kind of simplify this. They timestamp it, they measure the differences, and they do a mathematical formula that's about to it, and then they do several other ones after that are longer, and they come up with a point. It's a hyperbolic function, and the military uses this a lot. I mean, it's to the point where the military, if you hit your PTT button in a field someplace, the military can geolocate you within a microsecond. It's that fast, and it's that accurate. They can get down to meters with that. I only say that in this presentation because there are some people that are doing that with SDRs now, and they're playing around with it. It's getting better, but the drawback on this one is you have to have a lot of bandwidth on your, to get the data from the 3 transmitters, you have to have a pretty wide bandwidth, high signal, a lot of content. You're talking about megabytes worth of data that's getting processed. So this isn't something that you can do it with a Raspberry Pi and some SDRs, but you better have a really good, internet connection to all 3 places. So I just bring that up because it's kind of an interesting technique that a lot of people don't talk about. And so there's some professional equipment right there. That's the Rohde & Schwarz down on the lower left. It can geolocate transmitters using TDOA and angle of arrival, like the interferometer. It can also do it over 20 megahertz to 8.2 gigs. And this is kind of what the military is using too. They're doing it very, very quickly. If you go to some special events where they need a lot of security, you're going to see white vans and stuff out there with big, tall antennas on it. They'll have multiple antennas, and they're able to do this geolocation down to milliseconds. When whatever frequency you're on, they don't care. They'll be able to figure it out. They'll be able to also record you, so they'll know what you said, where you are, all that stuff. And that's what the military is doing real time right now. All right, so I'm about to wind this down. We're getting close to the end. I want to talk a little bit more about some of the software. So I think this is kind of what rounds out this whole program. So it's one thing to have a nice receiver, a good antenna, and some of the other parts we were talking about, the attenuators and things like that. The thing that kind of steps it up one notch for somebody that maybe is getting into it, doesn't have a lot of money, is they can use some of the software, and I'll show you how in just a minute, to help triangulate on a signal faster than it would be if you were to like plot it on a map or something like that. All right, so I know probably everybody here has heard of APRS, right? Anybody hasn't heard of APRS? Okay. All right, so APRS has been around for a long time. What is it, Bob Berniga? Is that his name? He came up with this. He was working for the Navy. He ported this over to amateur radio. Probably not very many people know that. Did he? Okay. I actually had lunch with him one day. We were talking about this at the very beginning, doing the direction finding stuff. So he added that software in while he was when I was talking to him at lunch. He was in the middle of doing that. So there are hooks in the original APRS that he wrote. I don't know if they ported that over, but they do have the ability to do Doppler plots on there and beam headings. You can do those manually, and you can add the fade circles. And the fade circles are really nice. So let's say that you guys had a jammer and you had a bunch of people all over Gwinnett County that was listening. You can add in the signal strength at your location on the APRS map, and it'll put a signal around you, and you can kind of quantify how strong that signal was. The signal gets stronger. I think you get a smaller circle. It's kind of backwards if you think about it. But you start putting these circles around there where you hear it, and you'll start getting overlapping circles, and you can use that maybe as a way to go in there and figure out if that's where the transmitter is. So you have the ability also to plot. Let's say somebody at, I don't know, Decula has a beam and they swing it. They give the beam heading in there, and somebody adds that into APRS. You don't have to throw it out on the network, right? You can have APRS go local. So you could have your own little private direction finding net using APRS. And I don't know if any of you are interested in that, but I would strongly suggest playing around with it if you do have any interest in it. I know that they used to have these hooks in there, and if you go on the APRS website, you'll see that they had, the last time I looked, they had the capability of adding these in there. So that's a nice little program that I think a lot of people know how to use. I don't know a lot about the Google Hunt GPS/DF. It's out there, it's free, and it works with Windows. I've just thrown it up there. I don't know a lot about it, so I can't answer very many questions about it. Basically, it allows you to plot up to 100 plots manually, or if you have an automatic Doppler, and then it'll just show it. I don't know if you can see it back there, but there's a Google Earth, and it has a bunch of bearing plots out there. So some of the more exciting applications, and I plan on, when I'm working with some people out at the fox hunt coming up, I want to kind of show people how to use the apps on your phone. I personally use SigTrax, which is the one on the right, because I have an Android phone. SigTrax will work on iOS or Android, but the Fox Hunt Pro on the left will only work with an Apple phone, and I don't have an Apple phone. I don't even know how to use it, so I can't really speak about that piece of software. But the SigTrax is done by a guy over in Birmingham, and he's a real nice guy, and he maintains this software. You can do manual plots on it. I will tell you, I don't know about the Fox Hunt Pro, but the SigTrax I think is like $5 to buy it. It's a nominal amount, and I know for a fact he's not making any money on it. I've talked to him a couple of times. He's keeping it up there because he really likes the hobby. Okay, so last part of the presentation. So let's talk about what you do before the hunt, where you're doing the hunt, and then probably the last phase of it. It may be where you're on foot, and we've kind of talked about that already. So for the pre-hunt, here's kind of a checklist. I won't read all these out, but it's kind of everything that we talked about with the receivers and the antennas and the preamps, GPS, and all that kind of good stuff. So I would have a list if you're going to do that. Put together a list, and there's kind of one up there if that's of an interest to you. All right, so finding the signal. I mentioned earlier that you may not be able to hear the signal at the very beginning. When I put together a fox hunt, I usually make it so you can't. One of the ones that we did with the North Fulton Club is we made it so that we were transmitting on the input of their repeater over there, which kind of mimics a real world situation where you got somebody jamming it or maybe a microphone stuck, but you could not hear it at the beginning. So people had to fan out. They had to use their capabilities of talking to each other, maybe teamwork, to try to figure out if they could hear it about where they could, and then they'd start direction finding it then. So I kind of like those hunts because it's more realistic than being able to hear it when you first start. But rest assured, we have made sure that you can hear the fox at the beginning on this fox hunt. So if you can't, you might need to go to a higher location. Use the lowest noise receiver. We talked about that earlier, maybe a preamp and a Yagi. What I'll do is I'll go find a high spot and set up a Yagi and turn it around and then get a bearing. And then I plot it on the software, and then I go someplace else. I do the same thing, and then where they cross, and I kind of go to that area. We'll talk about that in a minute. So that's what I would recommend when you can't hear it. And here's kind of an example. I don't know how well you can see that back there. I apologize for it kind of being blurred out. It's kind of a map over here that has a kind of a relief map look to it where it has the mountains. And what I'm trying to show here is that if you can't hear it when you first start out, you go to a high spot for your first bearing. This is kind of on a little mountain. We don't have a lot of them around here, but if you did, you go up maybe on this and take a bearing, and then you go to the next point and take a bearing, and then obviously where those things overlap is where you hope the transmitter is. I've also drawn some lines that are kind of off the edge of that, so there's going to be a beam width to the antennas and maybe some error. So you may not get exactly in that area right there, but it might be kind of an ellipse around that area that would help you get. So once you get in that area, you'll be able to direction find it better with some of the equipment we were talking about for close-in fox hunting. Okay, so one of the things to remember is altitude, the height. Get the highest place you can. You're going to get the better bearings there. And sometimes that's hard to find, but if you got a good topo map or something, you can, or you can use Google Earth. One thing that I found out the hard way is power lines are really bad if you're underneath those because they tend to make a lot of noise, and they also tend to re-radiate signals and stuff. So I wouldn't get around those at all because they're just going to mess up your signal bearing taking. I mentioned earlier Doppler bearings are better when you're moving. You want to keep track of your signal strength. One of the things that the Kraken SDR does that's really, really good if you look at their software is as you're driving around, it's plotting the signal strength. So even if you weren't getting good bearings from it, you could kind of see up here if it's a low signal strength as you're driving around, you can see it get stronger by the colors that it makes around there. You can almost use that to help get into the area better. But they also give angle of arrival, so you got two ways of determining the location of the transmitter. So if you're doing this kind of manually, I would kind of write down what the signal strength is as you're going along. Beware of reflections, buildings, stuff like that. Okay, so here's kind of a scenario I want to drive a point home on, and I don't know how well you can see this, so I'm going to try to describe it as best I can, but to talk about reflections and all that kind of stuff, if you had two groups starting out at the same point down here at the bottom, the red and the black team, so the black team starts off first, and it gets a bearing of the signal that's up here. So it starts driving up here and driving towards the signal, and then all of a sudden the bearing goes that way, and that's because there's this ridge right here that at the starting point you don't even get the direct wavefront of the transmitter because it's bouncing off this set of hills and stuff over here. So as they're driving along, they get all the way up here, and then they have to drive all the way back here. And let's say that's maybe 10 miles or so. The red team, they get the same bearing, but they decide that they're going to go off, and they could have gone off this way too, but I just happened to draw them going this way. They're still getting bearings that way, but they're going to the next highest peak, And once they do that, they see that they get it over here. And the lesson there is that if you're using Yagis and loops and all that stuff, it's probably better to go to 2 or 3 high points and make a bearing before you just keep going straight to where you think it is. The black team took longer to get there because they went straight to the signal source, but the red team took a bearing and then they went up to a high point and they took another bearing and they just luckily were able to drop in and see that it was down there. But even if they went to the other side, they would have gone up on a mountain and they would have seen it go over there too, and they probably would have beat the other team. You know, if you're into competition, that's fine. But I'm trying to drive the point home here that it really makes good sense to get up on high points as you're doing the direction finding. Now, if you're doing a Doppler, you can kind of drive around really quickly and probably still, beat somebody that's doing point-to-point measurement. But again, the point is the high points are where you want to go to. Okay, so you're saying which is best to put the fox at the low point or at a high point? So my question is, do you want to make it harder or do you want to make it easier?
It's subjective.
No, so answer my question. If it was low, do you think it would be easier or harder? I think it'd be easier.
If you're in the same valley.
If you're up on the top, you're radiating all over the place and you're bouncing over. There's lots of bouncing around. If you're down in a valley and you're hardly hearing it, it's going to start pointing more towards that. You get up on the top of that ridge and it'll point down in there, and now you're not going to, it's counterintuitive, I know, and I wasn't trying to be a smart aleck, but I'm just saying a lot of times if you want to make it harder, one of the hardest fox hunts I was ever on is a guy put it up on a high point. He had high power and low power every other. So he had something that switched between the two, and I thought there was literally 2 foxes out there. It was that confusing. Yes, sir?
The technology.
So, yeah, so it... You don't, and it can't. It really can't. So this, when you're out with an antenna or a Doppler or any of those other things, they're looking out horizontally. They're not looking down into valleys. And even if you went to the peak, they can, if it was down, a half a mile down that way and you're looking out that way, it's going to look like it's that way and not down. It can't do that. Now, with a beam, if you got it there, you can turn it down, right? But it's usually looking out. Now, I can tell you, I think you had a presentation on balloons, telemetry, weather balloons.
Long time ago.
Okay. So I've got a weather balloon tracking thing up right now, and I'm telling you, when that thing gets straight up on top of me, it's a little dipole hanging down from the balloon, and mine's a dipole up. My signal strength drops significantly, but then when it starts going out more away from me, all of a sudden my signal strength will pop up through the top. So, it has a lot to do with the type of antenna it is too.
So the hunts vary all over the place, Alex, to your point. About a month ago, up north, I follow a club up north where I grew up, and they held a hunt. Of course, it's flattish Indiana, so you don't have a lot of, and they did not do for time. They went for shortest distance traveled. So calculate precisely and move accordingly.
Yeah, so that's the way to even the playing field, right? So if you have people with Doppler, if you take everybody's, and they'll announce at the hunt which way they're doing it. If it's timed, the Dopplers may win. If it's less travel, then what you're talking about is if you take multiple bearings from high points, then you know about where to go and your travel time will be a lot lower. Okay, we're about to close it up here. So I apologize if you can't see this in the back, but there's a field out there, and it's just like a normal farm field, but there's a transmitter out there someplace, and you get the signal strength full scale, and you're standing there, and you're like, how am I going to find it in that? Well, we've talked about that. Some of the simple methods you could do if you don't have an offset attenuators, you can remove the antenna. And if it's a low power like this, you don't have one of your micro foxes here, do you? Okay. Oh, very good. So if you have something like that, you could probably get really, really close to it with the antenna off. If you got something more like the Baofeng that's a higher power, then you're going to need something like the offset attenuator or something like that, or the sniffer. I mean, so this could be a real situation at a fox hunt where you have a field like that, and they literally just stuck it out there someplace. So the equipment is important when it comes to that. Using your signal strength meter, maybe a body shield. If it's a high power, body shield is not going to work all the way. It'll get you close, but it's not going to get you all the way in. One of the things I really like to promote when I put a fox hunt on is I love people to work in teams. There are people that either don't want to or can't go out on the fox hunt, but they can sure get on their station and they can turn a beam. And they can call you on your phone or on another frequency, and they can give you a bearing, and you can have another friend do that. I recommend cheating like that all the time. And I like people to get used to that because we don't have a real big problem right now, but there was a time where we had people that were jamming our frequencies really, really bad. And I hear, because I look at comments from other people, there's some of that going on around the United States now, probably because of people getting Baofengs that are really cheap. My son, who just became a ham at the Stone Mountain Ham Fest, says that he reads on these websites where people say you can buy these radios and you can transmit on the ham band if you want to. Nobody will say anything about it because it's emergency preparedness. And if they are in an emergency situation, we're going to help them. I know we will do that. But the problem is a lot of them want to play with these things, and they want to, they're going to get bored with them, and some people are going to start doing bad things. So this teamwork thing, I think, is really, really important to learn how to do those kind of things as a collective group, kind of practice those things. These fox hunts do that. And so if, God forbid, we ever have a time where that happens and we got to defend these repeaters, then we can all work together to do it. So I really like fox hunts that promote that. We're not necessarily promoting that on this fox hunt, but maybe in the future we could do that. The other thing is, if you're driving around, you really should have a co-pilot. I have not done that. I'm probably the biggest center in the room for any of that stuff. But if you're not paying attention, you can run in the back of a car. So I highly recommend, Joe and I went out and was playing with one of the direction finders the other day. He was doing the laptop and I was driving, and we didn't hit anybody. So I really think that's the best way to do it. All right, well, I appreciate the time. If you have any questions, I'd be happy to answer them at this point. Yes.